Okay, I'm just going to write down what we've got so far. We know that x equals 2 sine bracket 3t plus 3 pi on 4. The main thing here is that you remember that later, when you come to sketch that is sine of 3 bracket t plus pi on 4. We did that yesterday. We also did the velocity equation. I'll just write down what it is. We got 6 cos 3t plus 3 pi on 4. Did we do the acceleration equation yesterday? I don't think so. No. So that's what we had yesterday. Yesterday, I'll just bring it down if you want. We found the times. This is what we did yesterday. Yesterday's lesson. We've got particles moving in simple harmonic motion, but this was the sine curve, but it doesn't matter. It'll work for cos and sine. All right, we did amplitude, center, period, initial phase. We did the times and positions when the velocity was 0. So we had x, and we differentiated it to get v. Velocity was 0, put v equals 0, and we solved for t. And then we got the first time that velocity was 0 was when time was pi and 4. And when time was pi and 4, we worked out the position of the particle. And that's all we did. Now, that's what we did last lesson. Now we're continuing. Our next question is to find the times, this is question C, the times and positions. Times and positions. Oh, actually, I haven't finished that first question. So find the times and positions, I haven't finished actually, when the velocity is a maximum. So this is still part B. So before we do acceleration, we're doing this. So the next part of this question is to find the times and positions when the velocity is maximum. Think simple harmonic motion. When is the velocity maximum? At the ends or in the middle? All right, so velocity is maximum when x is 0. Or you can differentiate and maximize, but I wouldn't. So we're going to go velocity is maximum when x equals 0. So we're going to, that's our equation for x. We're going to put, so therefore 2 sine 3t plus 3 pi on 4 equals 0. That will give us the time when the velocity is maximum, and then we'll work out the position by substituting into the x equation. So find the times and positions when the velocity is maximum. So velocity is maximum, this is really important, in the middle. X is 0, velocity is max. Okay? That's why we spent that lesson on that. In the middle, it's fastest. On the ends, it stops. All right? Acceleration is 0 in the middle too. All right? So, okay. Notice there's a link between x and a. If x is 0, a is 0. Because you know why? Because a equals negative n squared x. Do you remember that equation? So if x is 0, a is 0. Can you see that? Because of this equation. And when x is its maximum, say a negative, a will be the maximum positive. And when x is the maximum negative value, that's the maximum positive value. They're opposite in sign, x and a. And when one's 0, the other one's 0. When one is the maximum, the other one's sort of the maximum, but the negative, the minimum, I suppose you can call it. Okay? That's because of that relationship. So when we solve this, what do I do now? Divide. So divide by 2. So we've got that the sine of something is 0. So sine of what is 0, girls? Here's the sine curve, just a normal sine curve.
0.
Yeah, so therefore that 3t plus 3 pi on 4 equals 0. It also equals what? Pi and 2 pi. I'm not sure how far this motion is going. What's the period, by the way? 2 pi on 3. But we only want the first few times. So let's just put them all in. What do I do now? Subtract what? I'm trying to get t. So subtract 3 pi and 4. So that's equal to negative 3 pi and 4. What's pi minus 3/4 pi? That's really 1 minus 3/4. What is it? And we've got 2 minus 3/4 is 1 1/4, which is 5 pi and 4. We okay with that? because you're really just doing 0 minus 3/4, 1 minus 3/4, 2 minus 3/4, and just throw the pi on the end. And then we get t is, dividing that by all of those by 3, by 3 we get negative 3 pi and 12, which is negative pi and 4. Divide this by 3 and you get pi and 12, and divide this by 3 and you get 5 pi on 12. So t has to be greater than 0, so therefore the first time when v is max is time is pi on 12 seconds. Now, if we actually drew the curve, no, it's a bit hard to see it on the curve because there's the sideways shift. So when you've got a sideways shift, it's really hard to read it off the graph. You need to do it like we're using your trig equation. Okay, now, what do I do next? Find the times and positions. So when t is pi on 12, x is, and you work it out. It's 2 sine, I'm substituting it into the equation. Actually, won't that just be 0? I should be putting it into which equation? Into the velocity equation. Yeah, find the time and position. Oh no, we've done it. Well, it's at the origin, it's done. We're done. So therefore, first time when velocity is max is time is pi and 12 at the origin. We've already done that. Okay, part C. I know, I was about to substitute it back in and get 0 again. So we want to find the times and position when acceleration, so I'm doing when acceleration is first 0.
How many more questions have we seen? How many parts?
C's got 2 parts, part 1 and 2. So find the times and positions when acceleration is first 0. Just thinking about, look. When's acceleration 0? In the middle. So we may as well just, I'm sure we've done it in a previous part. Have we solved x is 0 yet? Yeah, we did. Yeah, we just did it. So we've just done it. So acceleration equals 0 when x is 0, which is at time t equals pi on 12 seconds. Okay? Actually, I better make sure that it does get there first. Depends where it's moving. Let me just double. Can I double? Oh, no, it should work because we're going to put x is 0 and we're going to get the same thing. I can draw the acceleration curve just to be sure. All right. Do we know it? All right. We'll do it in a sec. See, guys, it's from this graph. In the middle, x is 0, but acceleration 0 in the middle too, because you've got negative acceleration, positive, negative, and the middle 0. When you go from positive to negative numbers, 0 is in between. So acceleration 0 in the middle, and we know it is from this equation too. When x is 0, a is 0. Can you see it? The link between. This equation is very, very helpful. A equals negative n squared x. Okay? So time and position when acceleration is first 0. We've done it. Okay. Next bit. We want the time. So find the times and position when acceleration is first a maximum. Okay. So find the times and positions when acceleration's maximum. I'm going to leave this space here for my acceleration diagram whenever I draw it. But look at the particle. In the middle, x is 0, a is 0, v is max. Where do you think acceleration's maximum? But we've got to be careful. A is this forward? Remember, acceleration acts to the middle. So this is positive acceleration. Here's a is max there. Max in the positive direction. A is max in the negative direction over here. All right? Or you could call it a minimum, but I don't like to call it that because it's just maximum in the opposite direction, that's all. All right, so it would be at this time, which is when x is what? That's the negative, yeah, max, but what is the equation for x? X equals 2 sine 3t plus. The equation is x equals 2 sine 3t plus 3 pi and 4. So tell me what this value here is. X is what? Guys, on the ends of the motion, x is what? Amplitude's 2. This means the particle goes from 2 to negative 2. That's what that means. Yeah, this one's negative 2 and this one's 2. So acceleration is max when x is negative 2 because it's acting in the forward direction. We can have a look at when we put x is 2, you'll get the opposite. Now, instead of substituting, you should actually be able to tell me the position straight away because remember there's a link between x and a. All right, tell me how you want to do it. You can do it a few different ways. You can't, if you use a equals negative n squared x, that only links x with a but will give you nothing about the time. If you want the time, you're going to have to substitute something else in. So, sorry? V squared is n squared. That won't give you anything about time as well. So what are you going to do for time? I've got this equation here. If I put x is negative 2, it will give me, I can work out the time. All right? So to find the time, remember the time equations are only your simple harmonic equations. Either x equals whatever sine or cos, whatever t. They give you time. This equation relates time with x. The velocity equation will relate velocity with time. The acceleration equation relates equation with time. The differential equations, when you differentiate. But these others, that one relates x with a directly, and the v squared equals n squared a squared minus x squared links x with v directly. All right, but these are all the others. The x, v, and a ones will go through time. So to find time, we're going to sub x is negative 2. So we've got negative 2 equals 2 sine 3t plus 3 pi and 4. Now what do we get? Yeah, I'm going to look at that in a minute. One of them, but you know what will happen? If you put 2, you're just going to get the negative. It's still, yeah, but acting in the negative direction, all right? So what do we get here? Dividing by 2, you get negative 1. Now what do we do? Here's the sine curve. Sine of what's negative 1? So that 3t plus 3 pi and 4 must be 3 pi and 2 because that's the sine curve. Sine of what is negative 1? It's 3 pi and 2. Therefore, 3t is 3 pi and 2 minus 3 pi and 4. That's 1.5 minus 3/4. That's 3/4 because it's 1.5 minus 3/4. Because see, I know because my kids we're always cooking. And when we have to halve the 1.5 cups, it's 3/4 of a cup. So, yeah. And therefore, t is pi and 4 seconds. So therefore, now if you put the 2 in, the positive 2, you'd get this point up here, which is but that's the x equation. What would you get? One sec. You'd get pi on 2 minus 3/4 pi. All right. You know how, all right, when we'll do it in a sec, all right? So we're getting time is pi and 4 seconds. So when time is pi and 4 seconds, I don't have an acceleration equation. I haven't differentiated. Why don't we just go straight into this? Oh, sorry, yes, you do. X is, thank you, x is 2 sine 3 pi on 4 plus 3 pi on 4, because it's 3t plus 3 pi on 4, and t is pi on 4. 3/4 and 3/4 is 1.5. So it's 2 sine 3 pi on 2. What's the sine of 1.5? Negative 1. We know the position. We already told them the position. Do you get what you don't have to do that. It's -2. We know that. We said it was -2. You don't need to do that. We're finished. Therefore, acceleration, you don't need it. But you don't need it. Get rid of it. We've already got the position. Yeah, so acceleration is max. Yeah, that's the last line. When t is pi on 4 and particle is at, x is -2. See, this is the good thing about the motion. You know, for example, that at the endpoints acceleration is maximum. You know in the middle acceleration 0. You don't have to do this substitution. All right, if you put +2 here, you'd get a normal 1 and you'd get pi on 2 instead of 3 pi on 2 here. And a half minus 3/4, it would give you a negative time and you won't get an answer. All right, so that's why it has to be there. All right, okay, that's that one. So the times and positions when acceleration is first maximum is done. And now it just says the last question. Can I move on? Sorry, girls. X is -2. So the next one, part D, express the acceleration in terms of displacement. In other words, they want you to do, you know, the a equals -n squared x. They want you to prove that, okay? So we've got x equals 2 sine 3t plus 3 pi and 4. Look, we can do it. You actually don't have to prove it. You could just do it. Don't we know that acceleration is -n squared x? I'm going to do it the long way in a minute. But we could just do this. What does n equal? What does n equal? Remember, it's it's 3. So it's -3 squared, acceleration is -3 squared times 2 sine 3t plus 3 pi and 4. So it's just, wait, but this is not in terms of, isn't it just -9x? Yeah, I don't need that. It's just -9x. Express the acceleration in terms of displacement, it's that. -3 squared times x. Now, I can derive it and prove it if you're worried. Okay? We will. X is 2 sine. I've already done the first derivative before. I've got it. I won't make you do that again. The first derivative, actually I will. What was the first derivative? 6, wasn't it? 6 cos, let's just do it anyway, 3t plus 3 pi and 4. What's acceleration? Good practice, girls. Isn't it negative sine? Sine 3t times 3, so it's -18, isn't it? Sine 3t plus 3 pi and 4. We'll just do it. Now, how do I make that look like the x thing? What do I do? Do you remember? I need the 2 sine 3t plus 3 pi and 4, and I change what the 18 looks like, and I make it -9 times. Got it? So acceleration is -9x. So isn't this much easier? So that's proving it by differentiating. And because you want to write a in terms of x, write down your x bit and fill in the gap there. And a is -9x, which is of the form -n squared x, where n is 3. So we've proved. Now, actually, see how I did this? If the question does not say it's moving in simple harmonic motion, you are not allowed to write that. Okay? So this is for simple harmonic motion. Now, if I did not say anywhere in the question, I don't think I have, that this is simple harmonic motion, you're not allowed to prove it. Once they say it's moving in simple harmonic motion, you're allowed to throw that in. You're allowed to say, oh, it's simple harmonic motion, therefore, unless they ask you to prove it. All right, now the question actually didn't tell me that. So you might do that. So if you're told it's simple harmonic motion, then this rule does apply. You're allowed to pull it out and say it. Okay, last question. All right, we're doing, I'll start a new page. Okay, this one's got a shift up and down as well, and these tend to be tidal questions where the tide rises up and down. So this particular one's not, but we will do one today, I'm hoping. A particle is moving in simple harmonic motion according to the equation. Now, girls, this is the worst type you can get. If you can do this one, you can do them all. 2 plus 4 cos 2t plus pi on 3. First question, we want the centre, the period, the amplitude, and the extremities of motion, the endpoints. In other words, the maximum and minimum displacement. Now, you don't have to be able to draw it exactly with the shift. Well, you will eventually, but not yet, not for this question. But you should have a little bit of a sketch. I know that there's a shift, all right? Don't worry about that part. And don't, look, the few things that you could work out, what would be the normal amplitude? What would, if the 2 wasn't there? So I'm just going to go here. It would normally be 4 and -4. I'm not going to draw it on that. But when you add your 2, are you okay with that? So normally the amplitude would have been 4 and -4. This 2's got to do with the period and the pi and 3, or part of the pi and 3. You don't just say it's the pi and 3. It's actually not. I think it's pi and 6 is the sideways shift, not pi and 3, because you've got to take the 2 out, all right? So, but the 4 is the amplitude, but adding 2 to both those, tell me the extremities of motion. What is it? 6 and -2. So I'm just going to go -2 less than or equal to x less than or equal to 6. Amplitude is, what's the centre? Oh, where will the centre be? It's not at 0 anymore. It's at, the old centre would have been at 0. Yeah, the new centre is at 2. So the centre's at 2. The period is 2 pi on 2, the coefficient of the t. So the period's pi. The amplitude is 4. Do you want, we can do a sketch. What I'm going to do on the next line, or actually just here, that's 2 plus 4 cos, 2 comes out, t plus, has to be pi on what?
6.
Yeah, because 2 over 6, 2 pi on 6 is pi on 3. So girls, that is, I actually want to do a nice sketch, even though we don't have to, but I want to do one now, because you're not going to like it. Right, it's moved up to 2. Extremities are 6 and -2. We've got, guys, it's been shifted up to, amplitude's 4, period is pi. This can be a real great one to draw. That's where it starts at -pi and 6, because you know how it's, so instead of shifting it, you can start it at -pi and 6 if you want. That might be easier. Does that sort of, or no? Normally it'd start at 0, wouldn't it? But no, because there's a shift of pi on 6 to the left. So either you decide to call this, or if you do want to start it at 0 and it's shifted, I'd rather start it there, okay, and go like this. And I'm going to have to keep going a bit to get a thing. Now, oh, wait, somewhere along here. Look, this is halfway. That's full way of one full period. Now, if the period is pi, so the distance from there to there is pi, isn't it? So what's -1/6 plus 1? It's -1/6 plus 1. That's 5 pi and 6. Pi will be somewhere here, but I'm not sure exactly. All right? Now, what's this point here at the bottom? What's halfway between negative 1/6? Well, isn't it pi on 2? Isn't it negative 1/6 plus a half will be where that is? So you've got negative 1/6 plus 1 gave me the 5/6 there. Negative 1/6 plus a half will give me the halfway mark because the period is 1 pi. Negative 1/6 plus a half, isn't that a third? So this position is pi on 3. What's the quarter-way mark? Like here, these are the quarter-way marks. What's negative 1/6 plus a quarter of the period? Do you see what I'm... But don't put the pies. You don't need the pies. We'll throw the pies on in a minute. That's 2 and that's 3. It's 1/12. So this is pi on 12. What's negative 1/6 plus 3/4 of the way along? That would be this one. See, this is the beginning, a quarter. I know I didn't start at 0, okay? I know I didn't start at... That's negative pi on 6 there. I started it there. Because it's really hard to try and draw it shifted along. All right?
So this is your origin.
But, yeah, my origin's negative pi on 6. Negative pi on 6 is my origin. Negative. You can't see that very well. It's negative pi on 6. All right?
Do we have to sketch these?
Look, I'm just sketching it. You know why? Because when we do all the other parts, you'll see how it fits in. All right?
Well, like, what if we couldn't sketch it?
You'll have a problem with the title question if you can't sketch it. But hopefully, listen, but the title questions don't have a shift sideways and a shift up and down. All right? Because they're just too hard when they're shifted both. But this is shifted both. So a title question, I'll double check, should only be... Okay, guys, what's the initial phase? I've really got to get this checked out, but we're going to call it what? Yeah, but the shift is not pi on 3, it's pi on 6. I need to get that checked, all right? But did you see it asked at all? It's never asked. All right, when t equals 0, what does x equal? So the initial phase is that. Where is the particle at time is 0? So I'm just, sorry, I haven't put the question. When t is 0, where's the particle? All right, I'll write down. Find where the particle is at t equals 0. Go. Yep. Where is the particle at t is 0? Where is the particle? What have we got? I want to finish this. Where is the particle at t is 0? We get 0 equals 2 plus 4 cos 2t plus pi on 3. I probably should have done it this way when I sketched it, but I just thought it... Thank you. Thanks, girls. So, where is it? 2 plus 4 cos... What? Pi on 3, thank you. And I'm sorry about the mistake. 2 plus 4 times, what's cos of 60? A half. It's 4. So you know how I started this graph? So here's 0. There's my 0. So the particle is at x is 4. So I could have actually just put the axis there and started drawing. Do you know what I mean? Probably. You got it? Anyone got a red pen or something? So girls, if you wanted, there's the axis, the real axis. Got it in red? Got it? That's 0. Shh, guys. Right, so if I did want to put the real graph, see how I did it from negative pi on 6? You can do that and then go and stick in your new axis if you want. See what I'm doing? All right, but that's the real axis, starting at 0. All right, so where is the particle at time is 0? It's at x is 4. So we got 4 meters to the right of the origin. No, it's not meant to be. I made it like that. Look, if that was just 4 cos 2t, I want you to find the first time when the particle is at the center of motion. Is at the following. Center of motion, you can see it already from the diagram. We've already done it. So find the first time when the particle is at the center of motion. By drawing the diagram, you can see it.
So what is the center of motion?
The middle of the amp. So it goes from there to there. The middle is this line.
So is that the amplitude in other words?
No, it's halfway between the extremities. A particle in simple harmonic motion goes like there, back, or up and down. Center of motion is the middle. So where's the middle distance between? Yeah, it's at 2. Now, we can solve this a few ways. Yes, I've already drawn the graph. I'll tell you why I like the graph. All your answers are there already. The center, you tell me from the graph when is the particle first at the center of motion. All right, we're expecting that answer. All right, it's pi and 12. You can see it from the graph, but I'm going to do it, if you're not graph people, we're going to do it by substitution. So particle is first at center of motion when what? X is 2. So let's put X is 2 into the equation. So we get 2 equals 2 plus 4 cos 2t plus pi on 3. And when you do that, we're expecting, we know the answer already from the graph is pi and 12. Let's see what we get. What's 2 minus 2? 0. Now what do I do? Divide by, and you get cos 2t plus pi on 3 is 0. And therefore, that 2t plus pi on 3, don't look at that graph. Cos of what is 0, girls? There's a cos curve. Yes, pi and 2. So, but girls, I'm not going to just put that because sometimes when you subtract this and you divide, you could get a negative answer. So I'm going to put pi on 2 and, what's the other time?
3 pi.
Good. And now I'll subtract the third. It's all right. The first one's still going to be positive. So I get 2t. What's a half minus a third? Is it a sixth? And what's 1.5 minus a third? Is that 1 1/6? Must be. I think it's that. 3 on 2 is 9 minus 2, 7. Yep. So therefore time is, divide by 2, pi and 12, 7 pi and 12. Therefore the first time, girls, we saw it in our graph. The graph had the answer. First time at the center of motion.
Miss, if we drew the graph in our example, do we still have to write all that working out?
No. If you've drawn that, you can read the answers off the graph.
And we'll still get
Yes. So it helps to be a good graph drawer. So the first time when the particle's at the center of motion is pi and 12 seconds. Now, when is the particle first at the origin? That's a bit harder to tell from your graph.
So that's like pi on 6, pi on 6.
Pi on 6, 7 pi on 6. So, sorry about the writing. Pi on 6, 7 pi on 6. So time is pi and 12, 7 pi and 12. First time is pi and 12. But that one was easily seen from the graph. Next question. When is the particle first at the origin? Can I move?
Yep.
Sure? I'm going to have to finish this by video. So when is the particle first at the origin? So isn't that when x is 0? So 0 equals, I'm writing the equation, 2 plus 4 cos 2t plus pi on 3. That's what we're solving. So that's part 2 of part C. You know what to do? Oh yeah, we've only got 4 questions. So when is the particle first at the origin? So when does x equal 0? So we get -2 over what? Over 4 equals cos of 2t plus pi and 3. Now we need to listen very carefully. Girls, this is 2 unit now. This becomes a 2 unit question. This is cos of something is negative a half. You need to use the quadrants, but you've got to be very, very careful because you've got to use your diagram. Because cos of something is negative a half. So now, can you read that? That's negative a half. So what do I write? Quadrants what and what?
2 and 3.
Quadrants 2 and 3.
Yes.
I'm off now. So I'm going to finish this in here for those that are here. Otherwise you watch it. Yeah, that's okay. So it's negative a half. So we say quadrants 2 and 3. What's the acute angle? Acute angle 2t plus pi on 3 is? Cos of what is a half?
Cos 60.
Cos 60, so it's pi on 3. So now you need to do, now girls be careful, close the door. Continue this, it's the end of the lesson. I'll stop the video and restart from this question.